Assalamualaikum and very good morning. This question about motion along straight line, we pick up the question from SPM 2019, question number 12, paper 2. Okay, a particle move along a straight line such that its velocity given by v t cube minus 4t square plus 3t, where t is time in second after passing through a fixed point O. So, question first asks you find the initial acceleration. What is the meaning of initial? Initial means where the t is equal to left. Then we get the acceleration from v. So we differentiate v respect to t. So we get a. So we differentiate v respect to t. We get 3t square minus 8t plus 3. Then to find the initial acceleration, we just substitute t equal to left into the equation of a. So 3 times left square minus 8 times left plus 3, we get 3. So this is how to visualize the condition of the particle when t equal to left. So the acceleration at t equal to left equal to 3. Okay, next the question B asks you to find the time interval when the acceleration of the particle is less than 6. So means a less than 6. What is a? A is 3t square minus 8t plus 3 less than 6. We will use the quadratic inequalities to solve this problem. In this case, we arrange to the general form and then we factorize the general form 3t times t less than left. So we fulfill the bracket with plus 1 and minus 3. I prefer to use graph method to solve this problem. So I sketch graph of quadratic with t-intercept is -1/3 and 3. Since in the question where t is time in second after passing through a fixed point O, so we just calculate the time start from left. Since the inequality is less than left, so we shaded the area under the t-axis. So this area means the time interval when the acceleration of the particle is less than 6. So the answer is t between left and 3. Okay, next for the question C. Question asks you to find the time when the particle stop instantaneously. What is the meaning of stop instantaneously? Means that when the value of v velocity equal to left. So we just substitute the value of v t cube minus 4t square plus 3t equal to left, and then we factorize t. So we get t times t square minus 4t plus 3. The value in the bracket can also be factorized. So we just constructing two bracket with t times t, and then we just substitute -1 and -3 to complete the factorization. Hence, when the particle stop instantaneously, the value of t is left 1 and 3. However, in this case, we just accept the value of t is 1 and 3. Actually, when the particle stop instantaneously, it means that the particle is changing the direction. In other way, it's also mean turning point. So we can see here the turning point happen when t equal to 1 and t equal to 3. Okay, for the last question, question C asks you to find the total distance traveled by the particle until the particle return to the fixed point O for the second time. Okay, in this case, time in second after passing through a fixed point O means the particle start here. So the particle start moving to the left and then turning point at t equal to 1 and then return to the origin at the first time here. Since the question asks you to find the distance travel until particle return to the fixed point origin for the second times, so the particle continue traveling to the right and then make turning point at t equal to 3, finally reach the fixed point O for the second time here. In this case, we must find the equation of displacement by integrate v respect to t. So the displacement function is t power of 4 divided by 4 minus 4t cube divided by 3 plus 3t square divided by 2. So when the particle return to the fixed point, actually the displacement is 0. So we just make sure s equal to love to determine the value of t when the particle at the fixed point O. Then next we time the equation by 12 to turn the equation into general form. Then we factorize t square, so we get t square times 3t square minus 16t plus 18. Since we cannot factorize the value in the bracket, so we use formula, and then we'll get t equal to 1.61 and t equal to 3.72. So to make it clear, when the particle return to the origin means that the displacement s equal to love. So when s equal to love, the value of t is 1.61 and t equal to 3.72. When the particle return to the origin for the first time, the time is 1.61. So the location is here when t equal to 1.61. And then when the particle return to the origin at the second time, the t is 3.72 and the location of t for the second time is here when t equal to 3.72. So now we know the time interval when the particle return to the fixed point O for the second time. So the total distance traveled by the particle until the particle return to the fixed point O for the second time is when t between love and 3.72. So to find the total distance traveled by the particle until the particle return to the fixed point O, I prefer to use area under graph of velocity. So we sketch the graph of v, and then we identify that t axis is t equal to love, t equal to 1 and t equal to 3. So since we want to find the area travel until t equal to 3.72, so we find the area under the curve until t equal to 3.72. So the area shaded by the purple color show the total distance traveled by the particle. We integrate v from love to 1, we get 5/12. And then plus we integrate v from 1 to 3, we get 8/3, and then we integrate v from 3 to 3.72, we get 2.24. So the final answer is 5.33 meter. Okay, that's all from me. Thanks for your time watching this video. Hopefully this video will help you to understand about motion along a straight line. Thank you. Don't forget to subscribe.